Hey guys, let's take a look at this is a couple of problems here in section 4.3. We had questions on number 20 and 21. So I already have 20 here on your screen. And when I saw this problem, this is how I thought about working it out. So the function in this case was 7e to the x cosine x. And what we're asked to do is find the critical point and then state whether that critical point is a maximum or minimum using the first derivative sign test. Okay, no problem. So since it involves a trigonometric function, it had to give a domain restriction. In this case, it's from negative pi over 2 to pi over 2. I go ahead and take my derivative and try to find any critical points within that region. So my derivative, I said derivative of the first, that's going to be 7e to the negative x times the derivative of that exponent negative 1. So I get the negative 7e to the negative x cosine x plus the first, now times the derivative of the second. Of course, derivative of cosine is negative sine. That allowed me to see I could very easily factor out that negative 7e to the negative x. When I do, I'll have left over the cosine x plus a sine x. And now to find the critical points, we set that equal to 0. Okay, you know an exponential function can never equal 0. That factor is always going to be negative. Set my second factor equal to 0 by just saying, well, that's going to be true when the cosine is equal to the negative sine. And then if you just think about your unit circle, that should be pretty easy. We are only looking at angles between negative pi over 2 and pi over 2. The only angle in that region in which the cosine is the negative of the sine is at negative pi over 4. At that angle, the cosine is the negative of the sine. So we can say, okay, negative pi over 4 is our critical point. Now, is that critical point a maximum, minimum, or possibly neither? Well, we do our first derivative sign test by breaking up the domain of the function with that critical point. My first test region goes from negative pi over 2 to negative pi over 4. My second goes from negative pi over 4 to pi over 2. I chose negative pi over 3 to represent that first region, and I chose 0 to represent the second region. Now, we're plugging those test points into our factored version of our second derivative. We already know no matter what we plug in, negative 7 times an exponential function is a negative factor. What's going to determine the sign of this first derivative is that second factor there. So I really thought about this one. And I said, well, what happens if I plug in a negative pi over 3? At negative pi over 3, your cosine function is going to be positive 1, but your sine function is going to be negative square root of 3 over 2. So that tells me that that second factor would be negative. I would have a negative times a negative, which I know is a positive. Remember, I don't care about what the exact number is. I only care about what the sign of the number is. Anywhere where the first derivative is positive tells us that the original function is going to be increasing. So right now we know that the original function is going to be increasing up until the critical point at negative pi over 4. At any critical point, you know that the function flattens off there. So we have that part. Now, on the other side of pi over 4, I choose 0 to test that interval. It's easy to plug in because you know the cosine of 0 is 1, the sine of 0 is 0. Therefore, that second factor is positive, and you'll have a negative factor times a positive factor. You know your first derivative is going to be negative in that region, which tells you that your original function is decreasing in that region. So I can say, okay, it's increasing before the critical point, decreasing after. Then that location at x equals negative pi over 4 is the location of a maximum due to the first derivative sign test. Now, I go in here and I try to enter in that information. First of all, I'll say negative pi, and we have that divided by 4. And then this critical point is, and we just discussed, it has to be a maximum. So I'll check that, and it's saying correct. Now, the next question was 21, and let me show my work for 21. So we were given this function f of x, which was equal to the inverse tangent of x minus 8x plus 4, and the domain is all real numbers. So I just go ahead and take the derivative here. Derivative inverse tangent is 1 over 1 plus the argument squared, so 1 over 1 plus x squared here. Of course, we had to multiply it by its constant coefficient of 16. minus the derivative of 8x, which is just minus 8, of course, derivative any constant 0. We set the derivative equal to 0. I did that by moving the 8 to the other side. And then I know I could multiply both sides by 1 plus x squared, which gives me 16 equals 8 times 1 plus x squared. I know that that's going to be 8 plus 8x squared on the right. I'll go ahead and subtract that 8 on the left. 16 minus 8 is 8, of course, and I'll have the 8x squared on the right. Divide by 8, those eliminate, and you got x squared is equal to 1. Well, take the square root of both sides, you're going to get x equals positive and negative 1. So going back to the achieve assignment, you can say, well, the left critical point is at negative 1. The right critical point is at positive 1. But now it's asking us, is there a maximum or minimum at each of these values? So I have the critical points. I'll go ahead and now do my sign test and say, well, in order to determine whether there's a maximum or minimum at each of these, I would go in and say, well, I'll need to test from negative infinity up to the first critical point at negative 1, then go from negative 1 to 1, and then test from 1 to infinity. In each of these regions, what you're going to do is choose a test point, and I'll say, well, okay, the test point for this first region, some number between negative infinity and negative 1. I'll choose a negative 2. Some number between negative 1 and 1, I'll choose a 0. And then some number between 1 and infinity, I'll choose a 2. Nothing special about those test points other than, of course, they are in the region they're supposed to represent. Now, my first derivative was 16 over the group 1 plus x squared, and then we have minus 8. And all we're trying to do is determine the sign of this first derivative at each of these values. So, for example, if I plugged a negative 2 into this, you say, well, that's going to give me a positive 4 plus 1. Your denominator is 5. You're going to have 16 over 5 minus 8. I don't have to worry about the specific number. I know 16 over 5, it's less than 4. And any number less than 4 minus 8, it's a negative. And again, remember, we don't need the actual number. We just need the sign of our first derivative. When I plug in a 0, I would get 16 over 1 minus 8. Clearly, that's a positive. When I plug in the 2, I'll get the exact same answer as if I plugged in a negative 2. It would be 16 over 5 minus 8, which is a negative. So now I know that my function is decreasing before my first critical point. So we know it flattens off at each critical point at negative 1 and 1. My function is going to be decreasing until it gets to the critical point at x equals negative 1. It flattens off there, and then it's going to increase until it gets to the next critical point, which is at x equals 1, and then you're told it decreases after that. So you know your function looks something like that, and you can say, well, then clearly negative 1 is the location of a minimum, positive 1 is the location of a maximum. So I'll go in here and say negative 1 minimum, positive 1 maximum. So x equals negative 1 is the location of a minimum here, and positive 1 is the maximum. This should be exactly what they want. We go to check answer, and oh no, the page timed out. So hold on, I'll have to reload the page real quick and then answer it. I hate it when it does this. So I'll scroll down. 21. Left critical point was negative 1, and we know that that was a minimum. Right critical point was 1, and we know that that was a maximum. Now check answer, and okay, achieve, come on. Try it one more time here. I'll do this, guys. Maybe if I redo the whole assignment here. We already have the answer. It's just a matter of making achieve accept that answer. I will make it accept the answer. We have an answer at negative 1, and that is a minimum. And then the answer for the right critical point is at 1, and that is a maximum. And then I go to check answer. Come on. Oh, yay. Okay, accepted the answer this time. Sometimes for these problems that require more time to work, before you put the answer in here, you may want to refresh your page just to make sure you don't get that oops error. It seems like if it takes you more than 5 minutes to work a problem, Achieve tends to have trouble. So at least they don't change the problem. So whatever work you've done will still be okay for the regenerated page. Okay, guys, hope this helps out with this section. Let me know if you have any other questions.